Organic nomenclature. This is where you learn how to name organic molecules, and there is a systematic procedure that we use to name molecule to molecule to molecule. And the first thing we're going to talk about is the prefixes and suffixes that are utilized in the context of functional groups and the number of carbon atoms present in the molecule. So you may remember that we've already talked about the functional groups collectively as a family, but this time we're going to actually break it down into the specific molecule within the functional group. So you have your alkanes that only contain carbon-carbon single bonds, alkenes that contain carbon-carbon double bonds, alkynes with carbon-carbon triple bonds, nitriles, you have your triple bond between carbon and nitrogen. You have your carbonyls between carbons, which are the ketones. Carbonyl with at least one H bound to the carbonyl carbon, that's your aldehyde. You have your alcohol functionality, your carboxylic acid functionality, etc., etc. Now the ones that we're going to focus for naming purposes in this class are the alkanes, the alkenes, alkynes, alcohols, ethers, and the aromatic substances. The other functional groups, you will investigate their nomenclature in the second part of organic chemistry. So we're kind of like breaking it up in halves. All right, so the way we end up naming the molecules, as I implied earlier, is based on the number of carbons present in them. And depending upon what that number is, you use a different prefix for the naming. If you have only one carbon atom in your organic molecule, the prefix you use is meth, not to be confused with some illicit substances which don't really have a single carbon. There's a lot more carbon in those type of molecules. But anyway, one carbon, meth. Two carbons, eth. Three carbons, prop. Four carbons, bute. And from here on out, the number is simply given with the prefix that you will use for the corresponding polygon. So a polygon with 5 carbons is penta or pent. One with 6 is hex, one with 7 is hept, right? So pentagon, hexagon, heptagon, if you think about the polygons. The first 4 are the ones that are very unique to organic chemistry: meth, eth, prop, and bute. After that, 8 to 10, you have oct, non, and des, right? Kind of like decimal, des. And I'll even include 2 more: 11 carbons in total, 12 carbons in total. This will be undec and dodec. Okay, so dec, undec, dodec. Those are all the prefixes we will use in connection with the number of carbons present in the molecule, the main portion of the molecule. Now, as far as the suffixes are concerned, this depends on what kind of functional group you are dealing with. If it so happens that this is an alkane molecule, then the suffix is ane, like alkane, ane. So in the case of having only one carbon, this will be methane. Instead, in the case where you have 2 carbons, it will be ethane, propane, butane, pentane, hexane, etc., etc. If the molecule instead happens to be an alkene, then you use "ene" as the suffix. So this becomes ethene, propene, butene, pentene. Notice that I excluded meth from the name because methane is not really an alkene, because that would imply that you only have one carbon. And for you to have an alkene, you have to have a carbon-carbon double bond, which in and of itself means that you have to have at least 2 carbons. You cannot have an alkene with just 1 carbon. Alkynes. Use the ending of alkyne, "-ine", for the name. And once again, you need a carbon-carbon triple bond, so at the very least you need 2 carbons. So we're going to start with eth. So this could be ethene, or excuse me, ethyne, propyne, butine, pentine, etc., etc. And then there's this one that's a little bit funky, so let's make sure I don't mess up the pronunciation. So this is anol, okay, for alcohol. And you simply add it as a suffix to the to the prefix. And here you could have an alcohol with only one carbon. There is no restriction, right? That's only for alkenes and alkynes that have to have 2 carbons at the very least. For alcohols, you could have only one carbon and still be an alcohol. In that case, we're talking about methanol, ethanol, propanol, butanol, depending on how many carbons we have, right? So anol, not to be confused with other things. And then finally, you could actually have an organic molecule that itself has a smaller organic fragment kind of coming out of it, branching out from it. In which case the organic fragment is given the substituent YL. And if it happens to be only one carbon that's sticking out of the main framework of the molecule, then you will call it a methyl group. If it's 2 carbons in a row, then it will be an ethyl group, propyl group, butyl group, etc., etc. And I'll show you a few examples of how this plays out. But this is the overall playing field that we're going to concern ourselves with. In due time, we'll talk about the nomenclature of ethers as well. But first, let's look at some simple examples. We have the alkane molecule right here, which has 5 carbons. So if you count, you have 1, 2, 3, 4, 5. We have 5 carbons present in there. And for 5 carbons in a row, we go with the prefix pent. This happens to be an alkane, so we're going to go with the suffix ane. So the name of this molecule is simply pentane. Okay, let's do another one. We have this other molecule, and we count from one end of the molecule. So we have 1, 2, 3, 4, 5, 6, and 7 carbons. 7 carbons, and this is connected to an OH functionality. So this is an alcohol functionality. So we're dealing with an alcohol. We have 7 carbons, so we have the prefix hept. So the name of this molecule is heptanol. Okay, here goes another one. We have 1, 2, 3 carbons. 3 carbons implies a prefix of prop, and this happens to be a double bond, so this is an alkene as well. So we have prop and ene, hence the name being propene. All right, here comes the last simple example. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons in a row. Okay, and we have a triple bond, so we have an alkyne in this example, and we have 11, so that will be a total, and here we go, all labeled 11 carbons. We have undec as the prefix, so this ought to be called undecine, right? And this is how you would type it, undecine. And not to say that this is a super pretty drawing that I put in there, but it does look like one of a kind molecule, right? Okay, now let's talk about numbering as well. So we have the prefixes and suffixes. We could also include numbering in this discussion. So the deal is this. For heptanol, where you have 7 carbons, and this happens to be an alcohol, the hydroxyl group here happens to be at the end, at one of the ends of the organic chain. But that doesn't need to be the case. The hydroxyl group could be 1 carbon over from the end, 2 carbon overs from the end, 3 carbon overs, and so on and so forth. And all of these molecules will still be called heptanol because they all have 7 carbons in a row, and they have the OH functionality bound to carbon, which makes them alcohols. So the thing that will allow us to separate them and differentiate them and distinguish them from one another is where on the carbon chain is this hydroxyl group position. And technically speaking, what you do is you count from one end of the carbon to the other end of the carbon chain, right? So you go from 1 to 2 all the way up to 7. And when you do this, you say, oh, well, the hydroxyl is in position 1, so this is actually 1 heptanol. Whereas right here, the hydroxyl is on the second carbon. So this will be 2 heptanol. This one is on the third carbon. So this is known as 3 heptanol. And of course, the next one will be 4 heptanol. Now you might be tempted to say, oh, okay, well, then this one is going to be 5 heptanol, 6 heptanol, 7 heptanol. But here's a rule that you need to apply every single time. When it comes down to these functional groups like the hydroxyl, you have to give them the lowest number. And since we have an open-ended linear chain here, there is no restriction as to which carbon you select to be number 1. In fact, the one up here is no longer carbon number 1, it's the one down here. Because if you select this as being carbon 1, automatically you give that hydroxyl position the lowest number, right? So this is not 5, it's actually 3. This one is not 6, it's actually 2. And of course, that one is 1. And what this tells you is that these molecules down here are not new molecules. They just happen to be the first 3 that we drew, except that we just rotated them on, some arbitrary axis, right? So we rotated those molecules, but we still have 1 heptanol on both of those instances. We still have 3 heptanol on both of these instances and 2 heptanol in these 2 instances. So make sure that you give the functional group the lowest number when selecting the numbers. And this may mean that you will have to number from one end to the other and then do it backwards just to see which numbering gives you the better outcome. All right. In the next video, we're going to talk about the situation where you have multiple functional groups present in the same molecule and how you use the numbering scheme to name the molecule correctly. So see you in the next video.